going to wrap up chapter 3 today. Remember, on Friday we will be doing lab 10. And it's a really good one, so hopefully we're all ready for that. Alrighty, what I've got is I've got a few things we're going to discuss, and then I'm going to address a couple of things that are on the test, and we'll kind of go from there. Alrighty, so it is 1:26 today. This is Chem 11:10, Chapter 8, Day 3. This is second period. Our objective is going to be able to properly calculate dilutions. All right, now there's a main dilution equation, which is M1 V1 equals M2 V2. Now typically this is really straightforward. Okay, there's 4 variables there. What are they going to do? They're going to give you 3 of them, and you're going to solve for the 4th. That part is typically really easy. Okay, but there is one kind of question they ask that screws everyone up. Okay, that's the one I'm going to talk about. Okay, so what they do is it's going to look something like this. It would say, what is the final concentration of adding 82.5 milliliters of water to sorry, I don't need that A in there, to 125 milliliters of 4.2 molar solution. Okay. Now, M1V1, that usually stands for my initial molarity times my initial volume is going to be equal to my final molarity times my final volume, right? Now, as volume goes up, my molarity must do what? Must go down, because these are inversely related, right? Now, here's the question. What is this and this? They're my initials, right? Because that's what I'm starting with. So this is going to be my V1. This is going to be my M1. What is this? Okay, and this is where everyone screws this up. They just automatically assume, well, that's got to be V2. Well, why can't that be V2? Well, I start with this much. I can't end with only that much, right? Do you see what they're doing here? Now, usually that will be it. That's why you got to pay attention to how they worded it. Okay, I am adding that much to that much. So really my V2 is what? Yeah, it's going to be my 82.5 that I added to my 125 that I started with for, what did you get? 207. That's when you first said that. I thought, I don't. That's why I went right past that, if you noticed. Yeah. So that's going to be now, that's in milliliters, right? This is now my V2. So now I have 3 of the 4. Now I can go and solve this, right? So I'm going to have, 4.2 molar times 125 milliliters is equal to M2 times 207.5 milliliters, right? Now usually molarity is in what volume? And remember, it's usually in liters, right? Does it matter that these are in milliliters? No. Who knows why? They are still proportional, and what's going to happen when I do the math? Yeah, the key is they must be the same. So I'm going to divide by 207.5 milliliters, divide by 207.5 milliliters, gone, that's going to tell me that M2 is what? 2 point what? 2.5, big M, right? Now, what should I do right now? Besides move my mouse off the middle of my screen, because that drives me nuts. Nobody's ever been watching this online and that just has annoyed the crap out of them? Yeah, you know what I'm talking about, right, brochure? Okay, so, what should I do right now? Fisher. No, I'm not that much of a go-getter. I mean, you might be that much of a go-getter, but I'm not.
Oh, I'm not.
You're not. Oh, you were just telling me what I wanted to hear. Oh, just like a teenager, because that's what they do. Tori's on there going, yeah, buddy. Nobody? Just look at it. Cool guy. Jeez. Just look at it. And we just talked about this, right? My volume went where? Where did we say my volume went? It went up. So Harris, what did we say my molarity would have to do? Did it go down? Yes. Do I have a chance of being right? Yes. I'm not guaranteed, but you see what I'm saying? It's just a quick little. This is something I used to try to get my math, but man, they do not look at things and say to themselves, self? Is there any way that's the right answer? None of you ever do that?
No.
See, when you get older, this is what's going to happen. You're going to be married one day. Some of you anyway. That was funny. And you're going to go to say something to your spouse. And for a very split second, you're going to think to yourself, is this going to make things better or is this going to make things worse? And then you'll either be stupid like I am and say it anyway, or you realize, you know what, I'm just going to shut up now. And one day that's going to happen to you and you're going to think back to this moment. You're going to go, that's what Mr. Denton was talking about. And I am saying right now that you are welcome. Okay? Alrighty, now, there are a couple of questions that talk about what are known as colligative properties. Okay? Now, they do a very huge disservice to this unit on the test. They do. It's terrible. Hurts my heart a little bit, right? Now, there's a whole bunch of, not a whole bunch, but there's a couple of equations I would teach right now, and I would show you a bunch of things, but they're not on the test. So I'm like, why spend the next 20 minutes teaching you something that's not on the test? Okay? So, what I am going to teach you is what they're talking about, though. Colligative properties depend on the amount that is dissolved. Okay? Now, the easiest way to answer this type of question is to simply look at the number of ions. And let me explain what I mean. Let's say I take 1 mole of sugar and I take 1 mole of salt. Okay? Now, what you've got to do is you've got to remember first off, what is salt? Well, salt is NaCl, right? And sugar is C6H12O6. Now, sugar is what kind of compound? Does anybody remember? It's been a while, but I taught this once. Peyton. It's molecular. That's a great answer, by the way. Okay, what about salt? I heard it. Somebody said it. It's ionic. Why? It's a metal bond into a non-metal, right? You knew that, Simonson? No? Okay. Now, it's important you understand that because a molecular compound does not do what? Anybody know? It doesn't do something that an ionic compound does. Starts with a D. No, they dissolve, it doesn't dissociate. Okay? Ionic compounds, as long as it's not one of those that we talked about, will. So this gives me 2 ions, right? This one only gives me 1 molecule, right? Well, the more ions I get, the more I affect the boiling point elevation. The more I affect the freezing point depression. It affects them both. A little differently, but affects them both. So if I have 1 mole of sugar and 1 mole of salt, which one is going to affect my boiling point the most? The salt, because it gives me more ions. What if I did this? What if I did that one? What does that give me? Yeah, that gives me 3 ions. So it would now even be better. Now, Torgerson, I appreciate that. What did you immediately do? You looked at that to see if that did what? I first got to see, does it dissolve? If it does dissolve, then I got to figure out how many ions it gives me. Yes?
How are you finding the ions again?
I simply break this up. NaCl gives me 1 Na positive plus 1 Cl negative. CaCl2 is going to give me 1 Ca2 positive plus what? 2 Cl negatives. It doesn't give me a Cl2. You see what I'm saying? Yeah. So when it talks about colligative properties, just look at the number of ions. Okay, and that's going to tell you how to answer that question. Okay? Alrighty. Now, from there, where are we going next? Okay. If you noticed, and I know none of you read the chapters like I suggest, but every chapter has a health section in it where it talks about the human body or something, right? That's because this class, when they first started, was designed for kids that wanted to go into nursing or medical or anything like that, right? Well, very few tests they've given have actually had questions like that. Have you noticed it? Well, this one does. Okay? And we're going to talk about that. And it's when they talk about hyper and hypo. Anybody know what they mean? Biology questions? Yeah?
Hyper is excessive and hypo is deficient.
Okay, so, and in this situation, what they're going to do is they're going to talk about blood cells. Okay, so does anybody know what happens if I were to take a blood cell and I put it in salt water? It would shrivel. Why? What would happen? All the liquid in the cell would go out to try and do what? Yeah, it wants to dilute it. It wants to equal out the molarity, right? So what happens is it's going to be something like this. I've got hypertonic. And these are both solutions. I got a hypertonic and I got a hypotonic. Okay? And I'm going to put blood in it, right? So I'm going to take it, I'm going to put blood in each of these. Okay, now, in a hypertonic solution, okay, water will flow, as was pointed out. Water will flow out of the cell and do what? Does anybody know what happens when all the water flows out of a blood cell, what it's called? It actually has a medical term. It mentioned it in the reading. But again, no one does that. Now it's called crenate. And crenates. It means it shrivels up like a prune. You guys know what I'm talking about? Okay. Well, hypotonic obviously is probably going to be what? The exact opposite, right? Water will flow into the cell, and the cell will, anybody know what happens? It's going to burst. Let me know what that word is. No? Well, yeah, they're the same premise, but they actually have a specific name for this. No. It's called lyse. It will lyse. Okay, and what that means is it basically just splits wide open and as it basically explodes, if you will. It's kind of cool. We used to, when I was in college, we actually did this with onions. Peel an onion cell off, a sheet of onion cells, and you'd pass pure water across it, and literally you would watch the cells grow and grow and grow, and then literally explode like a balloon. Same way, you took salt water and did the same thing, and you could watch them underneath the. We had a microscope that you would project, and you'd literally just watch them shrivel, 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 shrivel. It's cool because we always did it first. So we passed regular water through, and they grew back up. A really good example of this is something I do every year. It's not going to work this year, which kind of upsets me. But let me show you something. Anybody know what that is? It's actually a peach. I've been working on this since September. Okay? Well, what's it done? It's shriveled up because it's basically doing what? It's becoming, starts with a D. Say it louder. Dehydrated. Okay, and date's an actual real fruit. They do dry them. They're like my favorite, by the way. Especially if you get good Middle Eastern ones. But yeah, it's dehydrated. So usually what I do is this is about a third this size. And it's hard as a rock. Because it's been 100% dehydrated. It hasn't rotted because it's been in the fridge. So the bacteria hasn't had a chance to grow. But what it will do is I usually put it in a beaker. And over a couple of weeks, it just, poof, just like it was the day it was picked. It's amazing. Which tells me that the surface, the skin of a peach, is what's called a what? Does anyone know what they call them? Nice. A semi-permeable membrane that allows what to leave? Water to leave, but nothing else. So when I put it in a beaker, over like 2-week period, it literally just swells back up, just like the day it was picked. It's really cool, but it's not small enough. If they get to the point where they need to be, I'll do it before the year's out. But usually I have them, but they just haven't worked very well this year. Okay. Now, going back to what was talked about, we need to talk about semi-permeable membranes. Semi-permeable membranes. Now, this is one of my favorite labs. I'm going to be honest, it's way cool. And we're going to actually do this. We're going to work with a semi-permeable membrane. Now, a couple of the questions on the test we're going to talk about is, let's say I've got a beaker. Okay, and that beaker is separated by one of those. It's a semi-permeable membrane, right? And initially I've got A and I've got B, right? Let's say A is 0.75 molar. Let's say B is 2.5 molar, right? Well, what's going to happen? Let's say I give this a couple of hours. Let's say I got 5 hours here. What's going to happen after 5 hours? What?
The B will go over to A and it'll be more equal.
Well, right now they're both the exact same level, right? Okay, what can move across this semi-permeable membrane? Just water, right? Blizzard. The B will go up. B's going to be like this. A is going to be like this. B and A. Why? Exactly, because what it wants to do is it wants to dilute it to make them the same, right? Well, to do that, the water is going to have to flow out of A and into B, which is going to make A more concentrated, and it's going to make B less concentrated. And if you leave it long enough, what would happen? They will equal out. Their volumes will not be the same, but the what? The concentration would be the same. Does that make sense? And understand, and we're going to do this. We're going to take a dialysis tubing, and we're going to tie one end off. We're going to fill it full of sugar water, right? And then we're going to take that and we're going to put it in a beaker of pure water. So I got sugar water inside. I got pure water on the outside. What's going to happen? Yeah, the water's going to flow where? Into the sugar water to try and do what? To dilute it, right? So what's going to happen is you're going to find the mass to begin with. And then you're going to find the mass at the end. Well, what had better happen? The mass had better go up as the water flows inside. And then we're going to do the opposite, and water's going to flow out, and you're going to do you're going to do some things like that. And it's actually really cool to watch. I mean, you don't see it, but to see what's going on there. Okay? Yeah. So that's that. Now, another thing we need to talk about is solvation. Okay, solvation. Now, this is one of those things that is typically fairly difficult for students to understand. Now, let's say I take and I put NaCl in water. Okay? Now, that NaCl is going to do two things inside that water. First thing it's going to do is it's going to do what? Anybody know? First thing they do? Starts with a D. It dissolves, right? But then it's also going to do what? Dissociate. How does that happen? What? Close. It's called ion dipole attraction. Okay? And what happens is this. Is initially salt comes as a crystal, right? The water molecules get kind of down in the nooks and crannies of that crystal and split the NaCl's apart a little bit, right? And then it gets further down right in between each NaCl and kind of pushes them apart as ones on the outside do what? Pull them apart. And it's called the process of solvation. And what happens is the Na positive and the Cl negatives are ions, right? Well, water is what kind of molecule? It's a polar molecule, right? So if you think about it, it's going to look something like this. Right? Doesn't water look something like that, kind of bent? That tetrahedral, lone pairs, bent. Remember that from a couple of chapters ago, right? Now, this is obviously partially what? Negative, right? This end then is, by default, it's going to become partially positive. So what it's going to do is this ion dipole attraction is it's going to allow it to basically get between those two ions and keep them from getting back together. It's kind of like your best friend and your boyfriend. She tries to... Nobody gets that joke. You know what I'm talking about? You do? Okay. Yeah. I had one of those experiences. So what's going to be on this end? Yeah, this would be where my sodium was, right? Because that's the positive would be bonded to the negative, right? Then the Cl negative would be on this end, and that's that ion dipole attraction, which keeps that salt from getting back together. That's why it stays dissolved in there. Now I could get the salt back by doing what? What? Yeah, heating it up, boiling the water off, and then the salt to get back together. But as long as that's there, it's going to stay dissolved because it stays in between there. Okay, and then it'd be like a whole thing. Then I'd have another water molecule here and another, you know what I'm saying? They would keep them separated. Okay? Now, yeah, just make sure we understand why that does that, ion dipole. It's a little different if it is a molecular substance rather than an ionic substance, but all they talk about is ionic. Okay? Now, who knows what the term saturated means? Not one person knows what the term saturated means. Nobody did the Learn Smarts. I have 3 of you that haven't done anything yet, which is a little disheartening. Fix it. But nobody knows what saturated means? Wow. Means it is holding as much solute as possible under given conditions. Okay, so here's an example. So let's say, suppose you have, I don't know, 80 grams of NaCl in 1 liter of H2O. Okay? Now, when they give you a mass like that, that tells you nothing. Nothing. Okay? So, mass is relative. Because if my water was at 10 degrees, it might be saturated because it's holding as much as it can, right? But how can I change that? Yeah, if I heat it up, now it's no longer saturated because the warmer it gets, the more it will hold. So understand that when they give you questions like this, mass has nothing to do with it. It's a situation. You got to look at it situation by situation. To be saturated simply means it's holding as much as it can under those conditions. It's like when you were a kid. Now I'm going to assume someone in here made rock candy as a kid. Anybody? Okay, well, how did you do it? You took a pan of water and you put a bunch of what? Sugar in it, right? No matter how much you stirred it, did all the sugar dissolve? No. So what did you do? You heated it up. Well, when I change the conditions, now it will dissolve more, right? Okay, well, how does it work? So I've heated it up, I've got all that sugar dissolved, right? So now it's saturated. But then I do what? I let it cool down. Now it is super saturated because as the temperature goes down, now it won't hold as much. So when you stick your skewer in there, what does that sugar do? It starts to attach to it because it is super saturated. And it attaches to it until it gets down to where it is now just saturated. If you let it sit long enough, it might actually become unsaturated as it gets bigger and bigger and bigger and grows on that stick or whatever. What? Yeah, if you leave it in there too long, then you're screwed. Okay? Because then it's just all the water's gone and now it's one big sugary crystal that you gotta never mind. You know how boys are, they're gonna try whatever they gotta do, right? Okay, so whatever. So just to understand, to be saturated holds as much as it can. We got super saturated holding more. We've got unsaturated, which means it's not holding as much as it can. But remember, all those values are relative to the given conditions. If I want to change the saturation, I'm simply going to change its temperature. Okay? So, there's a couple of questions about that. I just want to make sure we know what that means. Alrighty, now we are going to actually go right to a couple of questions that are on the test. Simply because of the way they've worded, I want to make sure we talk about this. Now, here's my question. So it says, what is the molarity of a 17.5% weight to volume solution of CCl4? Okay. Now, you need to understand something. I've got to go back and I've got to look at all my equations, right? Well, in all my equations, well, for one, I've got to use molarity. And molarity is moles over liters, right? Well, how many variables are there? 3, right? Well, what would they have to give me? 2 of them to solve that, right? Okay. But this is also talking about weight to volume, right? Well, who remembers our weight to volume equation? It was mass in grams divided by milliliters, right? And this was milliliters of solution, correct?
Yeah.
Okay. Well, again, how many variables are here?
3.
Isn't there technically 3 things here?
Yeah.
So they would need to give me 2 of them, right? But look at the equation or the question and tell me what's wrong with that. They only give you one thing. Okay? Now there's a couple of these questions. Okay? And what they do is they require you to make an assumption. And if you make the right assumption, it makes the question really, really easy. Okay? Now, if you notice, both of these equations require what? This requires volume of solution. This requires volume of solution. Don't they both require a volume of solution? Right? Well, if I choose the right value here, it makes this problem easy. Let me explain. We are going to assume 1,000 milliliters. Does anybody know why we're going to assume 1,000 milliliters? Because it's also 1 liter. Okay? Let me explain. So what I'm going to do is I'm going to assume I've got 1,000 milliliters of solution. Okay? So now I can go back to this equation and say, okay, if I assume I've got 1,000 milliliters of solution, I now have, it's my mass in grams over 1,000 milliliters, right? Well, I know that that's got to equal my weight to value, which was 17.5%. Now, there is one part of this we didn't put in there. Yeah, I had to times it by 100, right? Well, to make this math easier, I would simply take and put this back as a decimal, which would make it what? 0.175. Yeah, 0.175, right? Weight to volume. Now, when I do this math, times by 1,000, times by 1,000, that's going to give me what out? 175 grams of solute. Correct? Well, that really gives me 175 grams of what? Yeah, because we're talking about my CCl4, right? CCl4. Okay, now, the question, though, asks me to find the what? The molarity. So now I got to go back and remember, okay, molarity is moles over liters of solution, right? Well, what's nice about that? I got to go from grams to moles, but I already have my volume because we already assumed that it was 1 liter, which then makes the math pretty easy. So now I just got to take 175 grams of CCl4 and convert that to moles. How do I do that? So I'm going to take and I'm going to go 1 mole of CCl4 for every
153.823 grams.
Right? I do that math and what do I get?
1.137.
1.137 moles of CCl4, right? So that goes over here, 1.137 moles of CCl4 per 1 liter is going to give me simply 1.137 molar, right? But what would I need to do there? Yeah, sig figs. If you go all the way back to when I first started sig figs, I said what? Anybody remember how to do that? In the end, all that matters is what? Yeah, but say that louder. Go back to what was given. What's the only value they gave me? 17.5%, right? Well, how many sig figs are there? 3. I better make sure that my answer has 3, so my answer would really be 1.14 molar. Okay? Now, there are a couple of problems on the test almost identical to that. Just assume 1,000 milliliters because that does both this and that, and it makes the math really, really easy. Okay? If not, you wouldn't be able to even do the problem because they didn't give you enough information. And I think there's 2 of these, and when you get to them, you're going to say to yourself, oh, that's the question Mr. Dent was talking about. Does that make sense? Anyway, I'm hoping you do. That's why I'm covering it. Okay? Alrighty, now, from there, now, there is a question on the homework that everyone has been asking me about because I don't teach it, because it's not on the test, but there are two values you need to know. Okay, and what these refer to are boiling point elevation and the opposite of that is freezing point depression. Okay? And what happens is this, is why, okay, so when it snowed the other day, I'm going to assume some of your parents, probably your dad, went out and shoveled the walk, right? When he got done shoveling the walk, what did he do? Did he put anything else out? Yeah, he put, now understand, that was a female voice. Was that you? What did you say? Ice melt. You said salt. Are they the same thing? No. Okay, let me explain. Ice melt is like salt in that it's an ionic compound, but it is not just salt. Okay, when they use the term a salt, they simply refer to any ionic compound. But if they use the term just salt, now I'm talking about NaCl. Now, let me explain. NaCl gives me two ions, right? Gives me an Na positive and a Cl negative. Well, we already learned earlier that if I can get more ions out, I'm going to change things more. So, salt's great. Ice melt is better because ice melt gives me 3 for 1. So now I have to use a third less. Plus, typically, ice melt doesn't kill my lawn like regular salt does. Okay? Now, on the roads, they use regular salt because they're not worried about what? They're not worried about killing your lawn. Because let's face it, the side of our freeways look bad enough already. They don't care. You know what I mean? So it's kind of relative. So understand that. Now, boiling point elevation. Okay, there's a value and it's 0.51 degrees Celsius. Okay. And this is moles per kilogram. Okay. So for every mole per kilogram, it's going to raise it 0.51 degrees Celsius. Okay. Freezing point depression is 1.86 degrees Celsius per mole kilogram. And what happens is this is, you take how many moles you've got, you divide it by how many kilograms you got, and you're going to divide it by, or times it by that number. That's going to tell you how much you change it, right? So whenever you boil your water for spaghetti, right, what does your mom always do? She puts salt in it, right? Now most people think that is to raise the temperature, make it cook faster. It's not. Because if you really put enough salt in there to change the boiling point of your water enough, you wouldn't be able to eat it. Does anybody know why? It'd be way too much salt. Way too much salt. Okay? But notice how different it is. The freezing point depression, even though you got the same value, it affects it way more significantly. Okay, and this is why you do put it on your sidewalk, is because, you know, I don't have to put that much out and it melts the water, or melts the ice and allows the ice to run off my sidewalk, and then it can freeze whenever. Okay, but it's really kind of an amazing process, and it does the same thing. It goes back to this whole premise. Okay, the salt gets in between the water molecules and keeps the water molecules from getting back together and forming that solid. So it's just the opposite of what it does when it dissolves it. Okay, it's just looking at it from the other side. It's looking at it from the water side now. The ions get in between it. Well, if I get more ions, that's more ions to get in between more water molecules, right? And it keeps them from getting back together and creating that structure that it requires for it to turn from a liquid to a solid. By then it's all ran off your sidewalk dries, and then when it gets night, it freezes again, and that's fine because it's now no longer on your sidewalk. So it's kind of a cool little premise there. That's how that works. These are the two numbers you just need to know. I think there's like one homework question, but I've been asked it twice, so I thought, you know what, let's just hurry and cover that. But I truly feel that the test does not do Section 8A any justice. None whatsoever. Terrible. Okay? Now, like I said, the lab is vital. There will be a couple of questions on the test that you will be able to answer if you pay attention to the lab. They're not directly lab questions, but the topic they're trying to teach you in the lab translates to a test question. Okay? Any questions off the homework? Oh, wait, I forget. That requires you to at least start the homework. Do you remember the discussion we had about you not knowing what you don't know? Well, why didn't any of us change our behavior? Bray, you changed your behavior. Or have you always been doing it? Oh, okay. Go for it. So what they do is it simply gives you a question that says, which one of the following would affect my temperature the most, or something? Yes, because I believe the homework question gives you like all the same values, and then it gives you like 4 different compounds, right? I simply look at the compound and figure out which one of those gives me the most ions. Just what I talked about. Just to understand that's how it dissolves ionic compounds. You don't. That's the thing. The only way you really know that is through controlled experiments. That's why they don't give you all these values. You know, because water at 100 degrees will hold this much. Well, the minute I change that to 102 degrees, now it's going to hold more. So there's really not a way to just say. What they're going to do is they're going to look at it conceptually and say, let's suppose I have 30 grams of sugar in this solution. Well, you don't know if it's saturated or not unless they tell you a whole bunch of other things, right? So just to understand that the terms saturated and unsaturated and supersaturated do not correspond to any specific amounts. It's more of an idea. They're going to say, I don't remember the exact wording, but it's going to be something like, I've got 700 grams of water holding 100 grams of sugar. Is it saturated? Well, you're not going to know that. You know what I'm saying? So then they'll say something like, holy cow. I don't remember how they word it. All I wrote down on my note card to answer that was, saturated equals has no specific value. It is dependent on many factors. That's what I wrote down word for word on my 3x5. So you're probably going to have to read the question and ignore the what. Exactly. Does that make sense? It's got to be the way they word it answers the question. I know I just didn't want to give it away, which is why I wrote this down the way I did this morning. So what I wrote down was to try to answer without giving you the answer. So all I wrote down is has no specific value, which means you're not going to look at the numbers they give you. Is that right now? Okay. What? There's like one or two, but they're like obvious. When I looked at it, I'm like, oh, that's an easy question. Okay. I am still missing like 5 labs from this class. They're not in by Friday. I will not take them. Or no, Thursday. I will not take them. Okay, yo.
Lab 10.
Lab 10 is what we're doing.
Okay, no.
Wasn't lab 8 due the other day?
Yeah, I
Okay.
just asked about that.
Yeah, lab 10.
So what are we doing Thursday to review?
No, the lab 10 is on Thursday. Yeah, lab 10 Thursday. I'm ready to rock and roll. And then, yeah, we'll review Monday, test Wednesday. Okay? Okay, get busy. Use your time wisely.